So again,
Can I write down this one?
yes, but yeah, you don't need to actually. Okay. So kindly mute your microphone to avoid distracting your virtual classmates. And then only open your microphone when you have something to say. And then when opening your mic, please state your name before you say something so I would know who you are. And then be attentive and feel free to interact with the class. You may type in the chat box if you have any concern, but avoid flooding or spamming the chat box, okay, with unnecessary messages. Don't hesitate also to ask questions. Is my voice, guys, loud and clear? You can type it on the chat box, okay? Okay, good morning. So yeah, good morning, okay? Okay, great to know. Now, all right, so let's go directly with our lessons. Okay, so for our first question for this warm-up round, we have this one. Given A and B that are two non-zero digits and the two-digit number formed by these two digits have the following properties. So it should be divisible by 8, and then B, it is a prime number and is less than 50. Find the two-digit number. So how are we going to solve this? So to solve this, you need to take account, okay, the properties that were mentioned in the problem. So what I mean by that is these sentences. So we have this is divisible by 8, and then the other one is, okay, just give me a second. Okay, it should be divisible by 8, and that it is a prime number and is less than 50. So to solve this problem, guys, you need to take account first the first property. So divisible by 8. So what are two-digit numbers that are divisible by 8? So we could start with 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. So all of these are divisible by 8, okay? And we know that, okay? Because these are two-digit numbers. Basically, you can solve and find the numbers that are divisible by 8 by just multiplying it a factor of 8, correct? So in this case, you can also take note that the second property, B, tells you that it should be a prime number, okay? So when you see a prime number, it should be, it is a
61.
prime number and is less than 50, yes. So it has only multiple of itself and 1, correct? So BA should be a prime number and is less than 50. So that is the second condition. So when you transform each number here, okay, meaning uh, reverse the order, which is BA from AB, from the form AB, you need to reverse it into form BA. So 16 becomes 61, 24 becomes 42, and so on and so forth until 96 becomes 69. And then you need to observe whether it is less than 50 and it is a prime number. 61 is not less than 50, so that's not going to be our answer. 42 is not a prime number because it's an even number. 23 is possible. 84 is that's also greater than 50. 65 is greater than 50. 46, it is less than 50, but it's not a prime number. And then 27, possible, but that is not a prime number. 88, that's beyond 50, so that's not possible. 69 is also beyond 50, so that is not possible. So the only answer here in the problem is 32. Why is it 32? Because we're referring to AB. Okay, we know it's 23 when it's reversed in terms of order, but the actual or the original number that we are looking is 32. Did you guys understand? Okay, so if you understood, just type in our chat box yes or yeah, or any kind of confirmation that I would know also. Okay. Okay. And as much as possible, we use English in our chat because we are conducting this worldwide. Okay. So the next question is, Andy goes east for 12 kilometers, then goes south for 15 or for 5 kilometers. How far is he now from the original position? So the solution to this problem is very easy. You just have to know Pythagorean theorem. Yes, Pythagoras theorem, that's the same. So why is it Pythagorean theorem? It is because when you take note of the directions, this is north, this is east, this is south, and this is west, correct? So if Andy goes east for 12 kilometers, so Andy goes east for 12, this is 12 kilometers, and then goes south for 5 kilometers, so goes south for 5 kilometers. So basically, how far is he now from the original position? This is the original position, and then going to the final position. So basically, you are forming there a triangle with the side lengths 12 and then 5. So by Pythagorean theorem, yep, that is right triangles, okay? So by Pythagorean theorem, the square root of 5 squared, or the square of the side lengths, 5 squared plus 12 squared, take the square root of that, you'll have the answer for the third side. The third side will be 13, and that is going to be the distance from the original position to Andy's final position. Did you guys understand? Yes, it's the hypotenuse. Did you guys understand? Okay, great. Now we proceed. Let me know if you have questions in the chat, okay? So I would also see if there's, but so far there's no questions. So yep, we proceed to the next one. Okay, next, number 3. The cost of a teddy bear is $300. If the market price is $390, what is the profit margin in percentage? Okay, so let's dissect the problem. So we have the cost of the bear, okay? The cost of the bear is 300. If the market price is 390, what do you mean by that? So meaning the selling price of that teddy bear is 390. So let's say if I buy a teddy bear that is 300 and I'm going to sell it to this amount, 390. So I had this I had a increase in price or markup amount, which is $90, correct? So what is the profit margin in percentage? So when we say profit margin, that is gonna be the difference between your selling price or the mark price versus the original price or the buying price that you did prior to the selling process, okay? So 390 minus 300 over the original price, which is 300, and then take the 100, multiply it by 100% because we want to know it in percentage. So that's 3 over 10 because 90 over 300 is 3 over 10. And then multiply that by 100%, you'll get 30%. So that's a big profit for him because basically he's getting 30% of the original price just to like have a profit, you know? So yeah, it's a big profit. It's a big markup. So in business, we call that a markup price. Okay. So anyway, that's the answer, guys. 30%. Okay. So I hope you guys understood the solution. Okay. So yeah, we proceed with number 4. For number 4, we have here Amy, whose walking speed is 4 meters per second. Okay. She walks from home, okay, from home to the shopping mall, and from shopping mall back and forth 5 times in 15 minutes. What is the distance between Amy home and the shopping mall. So this is just gonna be easy, guys. You just need to take note that you are asked for the distance, correct? So this 4 here is in meters per second. This is the speed. So speed times time, okay, will give you the distance, correct? That's rate times time will give you the distance. So if I multiply 4 meters per second times the time, well, how much is the time? That's 15 minutes. But since the unit of your speed is in meters per second, so your time should be also in second for it to cancel out. So time should be in second. That's why we're converting 15 minutes to seconds. So that is total of 60 times 15. And then we divide it by 10. Okay. Why? Because the total distance should be divided by 10 because remember, Amy was walking back and forth. Okay. And then when we say back and forth, that means twice the distance, actual distance, correct? So since it's twice the distance, meaning it should be 10. So if it's 5 times and then it's back and forth, that's a total of 10 times passing through that certain distance. Okay. So here, 40 times 60 times 15 divided by 10, that's going to be equal to 360. And that is your answer. Meaning in meters, that's going to be 360 meters. Okay. So that's the actual distance from Ami's home to the shopping mall. Did you guys understand? Okay, great. So we proceed with the next one. Number 5. Okay, so for number 5, we have here a time or date problem. So 12th of May, 2018 is Saturday. Which year will 12th of May be Friday for the quickest case, or meaning the fastest way or the nearest date where 12th of May will become a Friday? So how are you going to solve that? So basically, you just have to add 1 on each year. Okay, if it's the same day, you just need to add 1. But there's a but. Okay, there's a special condition. So normally we just add 1. So from 2018 we add 1, 2019, so that's plus 1. But if it's a leap year, remember next to 2019 is 2020, and that is a leap year, meaning you're adding an extra 1. Okay, extra date, which is from when we know that if it's a leap year, February would be 29 days instead of 28, correct? So 2020 is a leap year. So you meaning that you need to add 2. So meaning 1 plus 2 plus for 2021, that is 1. And then going to 2022, that's another 1. And then going to 2023, that's another 1. Okay. So why are we doing, why are we stopping with 2023? Because we know it's Saturday, right? And then going for Friday, you would need 6 steps or 6 counts, okay? Because we know we have 7 days in a week. So from Saturday to the next Friday, that's gonna be 6 counts, correct? So what? So 1 plus 2, that's gonna be 3 already. Plus 1, 4. So from here we have 4, and then plus here we have 5, and then plus here we have 6. So we're gonna stop at 6 because we want it to be Friday. Now, after knowing that this stop here, okay, this particular stop here is what date? 2023. Okay. So by next year, 2023 of May 12, that's gonna be Friday. Okay, guys. So did you understand the problem? Okay, great. So let's proceed to the next one. So in the next one, there are 30 problems in a mathematics competition. The scores of each problem are allocated in the following ways. So 5 marks will be given for a correct answer. 0 marks will be given for a blank answer or wrong answer. Find the minimum number of candidates to ensure that 3 candidates will have the same scores in the competition. So this is using the worst case scenario, okay? So if you want to know the worst case scenario, guys, remember there are 30 problems, correct? And then basically it doesn't matter whether they got all perfect as long as they have the same score, okay? So 5 marks each. So the possible scores here would be from 0, you would get 0, 5, 10, 15, and so on and so on until you have like a perfect score, which is 150, because 30 times 5 is 150, correct? So the total, okay, the total number of possible scores would be 31. Okay, why is it 31 then? Because we're including 0. From 5 to 150, that's a total count of 30. But since we're including 0, because it's possible that that particular student, there's a particular student who can get like 0 score, okay? So yeah, it's 31. And then since we're looking for 3 candidates to be insured, okay? Meaning worst case scenario is 2 students would get the same possible score. So 31 plus 31. So that's one thing. And then we add another single score, which could either be among the 31 scores. You'll then get the total number of candidates, okay? So which is 63. So in this case, we need to maximize this. So possibly we have all these people, these 2 people here should have the same score. So the number of ways to ensure that would be getting all of the possible scores, correct? So 31 plus 31, and then add an extra score, which is among, it could either be 0, 5, 10, 15, or whatever it is. But yeah, that's 63 in total. Okay?
We use the pigeonhole principle problem.
Yes. Yes, correct. That is correct, man. So you are using the pigeonhole problem. That's why you add 1. Okay. But yeah, the trick there is you need to know that you have to multiply it by 2. Okay. That's because it's 3 candidates that you are looking for. Did you guys understand? Uh, Richard, re-explain number 1, meaning the first question. Were you able to miss? Did you miss the first question? Okay, so let's try to go back the first question since some of you missed the first question. Okay, so this is the first question. Okay, for those that who have missed the first question, this is a problem. You have 2 non-zero digits and 2-digit numbers are formed. So first case would be AB is divisible by 8. So possible numbers, 2-digit numbers would be this, 16 up to 96. So all of these are divisible by 8. And then the next condition is when you reverse the order BA, it should be a prime number and is less than 50. So how do you solve it? How do you do it? You just have to reverse all the numbers here, except for 40, because when you reverse 40, that becomes 0, 4. So that's equal to 4. And 4 is not a 2-digit number. So we don't need to reverse that 40 there. And then all the rest numbers would be reversed until 96, which becomes 69. 69. Correct? So the next thing is you need to take account that it should be a prime number and less than 50. So just do trial and error. These are prime numbers and even numbers that are bigger than 50. This is even, so it's not a prime. This is also not a prime. This is bigger than 50, bigger than 50. So you'll be left with 23. So now knowing that BA BA is 23, so therefore your original number, which is AB, is 32. Okay? Did you understand that, Richard? And the rest who have missed the first question? Okay, great. So let's proceed now to, let's go back to our last item that we ended up with. That's this one, number 7. We're already down to number 7. So for number 7, guys, we need to find the value of y. So if 4y minus 13 minus 3y minus 23 equals to 5. So how do you solve this? So basically, this is algebra. So in your case, secondary 1, you are very much familiar already with algebra. So what you need to do here is you just to put the constants on the other side, and then you should be left with a variable in the other side. So minus 13 minus 23, so minus 13 minus 23. So that becomes minus minus is plus. So this becomes plus plus, and then I think that's 10. So that's why it's plus 10. Okay. So y plus 10 is equal to 5. And then since you're transposing 10 to the other side, so that becomes 5 minus 10, which is equal to negative 5. So that means you're left with this final equation that is your y is equal to negative 5. So that's the answer, negative 5. Okay? Did you guys understand? Okay, cool. Yes, that's right. Then you need to break the bracket first. So if this is plus, you don't have to break the bracket. You can do it directly. But since it's minus, meaning you need to distribute the negative. Okay, so this becomes negative 3y minus, or I mean plus 23. Okay. Okay, so we proceed with the next one. Number 8. Okay, number 8. If x and y, okay, if x and y are positive integers and 3x plus 4y is equal to 33, find the maximum value of x plus y. So in this case, guys, you might think that the problem is hard because you're looking for the maximum, which might give you an impression that it's a hard problem. Okay, but don't worry because you have this specific conditional 3x.
I'm sorry, my device is kick me out automatically.
Yep, but we're okay. So you're back now. Doing okay. Okay. So the possible cases here.
Can you return to the question 7?
Question 7. Okay. Anyways, guys, if you miss any problem, don't worry because there's a recording. I've been recording this, so you don't have to keep asking the problem to be rediscussed because you can just watch it on the recording. Okay. So this is gonna be the last time that we're gonna re-lecture a certain problem because we might run out of time by the end of the lecture. So we need to finish this within 2 hours. So again, for number 7, okay, you just need to do algebra. So in this case, the negative sign should be performed first because you are distributing the negative sign. So when you distribute the negative sign, that becomes negative 3y plus 23. So 4y minus 13 minus 3y plus 2. So here you would notice negative 13 and positive 23, that's plus 10. And then 4y minus 3y, that's positive y. So in here, you can then transpose 10 on the other side. So that becomes y is equal to 5 minus 10. So that's equal to y equals to negative 5. And that is why we get negative 5 as our answer. Okay? Is that good doing?
Yes, I'm done.
Okay, great. So let's proceed now with our number 8 problem. So in this case, you just need to find the possible cases, okay? Okay, so here, what you're doing here is you need to try possible values. So possible cases would be if you pick your x. Okay, so choosing x. So when you start choosing x from 0 to 9, it should be 33 in total, correct? So here, we've tried 0, 1, 2. They wouldn't fit to 33. Any number here wouldn't fit to 33. So the only possible cases where the particular equation it is achieved by using x as 3 and x as 7. So the x as 3 and x equals to 7. So when you have x equals to 3, that becomes y is equal to 6. Because 3 times 3 is 9, and then plus 4 times 6. 4 times 6 is 24. When you add 24 and 9, that's 33. So check. Okay, this is check. And then when you add 3 and 6, that's equal to 9. But there's another thing, which is x equals to 7. So when you use x equal to 7, you'll have 7 times 3 is 21. So 21 plus 3 times 4 is 12. So that is also 33. So in short, 7 plus 3 is 10. So this is now the largest number that we can achieve. So the maximum value of x plus y, which is the largest one, should be 10. Okay, that's the final answer, guys. It's 10. Do you guys understand? Okay, we proceed with number 9. Evaluate this. Now, this one is a bit tricky because you have decimals on the denominator. But take note that 0.1 in fraction, that's just 1 over 10. 0.2, that's 2 over 10. So here you can see that we've transformed the denominator decimals in this form. So by transforming that in this form, 1 over 10 squared, that's equal to 1 over 100. Okay? So meaning you can base the rest. So you have 1 over 100, 2 over 100, 3 over 100. So all of them have 100 in the denominator. So in the upper part, you can basically solve this by just adding, right? So the sum of 1 to 10 is 10 times 10, n plus 1. Okay, n times n plus 1 over 2. So that's 55. And then since in the denominator you have 100, okay, you can factor out 1 over 100 in the denominator, right? So there's 1 over 100 in the denominator, and when you have 1 divided by 1 over 100, that becomes 100, correct? And that is why we multiply it in the numerator, the number 100. So when you multiply it in the numerator, that becomes 5,500, okay? That is because 100 times 55, which is 55 is the sum of all the numbers in the numerator. So in the denominator, you'll be left with 1 squared plus 2 squared plus 3 squared plus that plus 10 squared. So to solve this, you need to take account of the formula that we know. That is going to be n times n plus 1 times 2n plus 1 over 6. So this is the formula for the sum of squares, correct? So using sum of squares, you will get 385, and then getting the mixed fraction value, that's 14 and 2 over 7. So that is the final answer, 14, 2 over 7. Okay, so did you guys understand? $55 is multiplied by 100 again, because if you factor out the 10 squared here, everything you'll have 1 over 100. Okay, when we say factor out, we're basically removing the common factor. Okay, so this is 3 squared plus that 10 squared. Okay, so yeah, and then since it's in the denominator and you have 55 on the numerator. So 55, look at this part, 55 over 1 over 100, that's 55 times 100, correct? So this part here basically, yeah, because it's just a reciprocal problem. So 1 over 100, that's 1 over 1 over 100, that is 100. Okay. So any other question? None. So we proceed to the next one. Number 10. So for number 10, given that A and B are positive real numbers to satisfy equation A squared plus B squared is equal to 80 and A plus B is equal to 10, find the value of AB. Okay, so how are you going to solve this? Oh, okay, let's just, okay, go and screenshot it, Kyle. Are you done? Does that need to write the fraction as mixed number? Yes, you have to write it in mixed number. Okay, we proceed with number 10. Given A and B. Okay, so this is using algebraic identities. That's correct, Dui. You need to use algebraic identity. So in algebraic identity, what you need to know that A plus B is equal to 10. But A, remember that A, okay, A plus B squared is equal to A squared plus 2AB plus B squared. This is the identity for square of sums, right? That's a square of sum. So in this case, then we know this is 10. That's why we have it here. And then A squared plus B squared, this two part here when added is 80. That's basically in the problem. So you'll be left with 10 squared equals 80. So 100, that's 100 minus 80, you'll have 20 to AB. So divided by 2, you'll have your value for AB, which is 10. So here you would know that AB is equal to 10. So yeah, by just using the algebraic identity, you can get the value of AB without really getting what's A and what's B. Okay? Did you guys understand? Okay, we proceed to the next one. Number 11. For number 11, okay, for number 11, you need to just find the value of x. So to solve for the value of x, guys, the easiest way to solve it is by what you call this one? Linear equation. So solving pairs of linear equations. So in this case, okay, so x plus 2y is equal to 3, and then we have 3x minus y is equal to -5. So what we did here in the problem is we multiplied this equation by 2. Okay, why did we multiply it by 2? That is because we want to eliminate 2y. Okay, why do we want to eliminate 2y? Because we're looking for x. Okay, so we want to eliminate 2y because we're looking for x. So if the problem is looking for y, then we want to eliminate x. So in that case, if the problem is looking for y, you'll multiply x plus 2y by 3. Okay, so in this case, we're looking for x. So we're multiplying the second equation by 2 to get this one. So 6x minus 2y is equal to -10, which is basically giving you same. Okay, you see there's 2y, there's positive, negative. So when you add the two, when you add them, okay, add these two, Add the two equations, 6x plus x, that's 7x. 2y minus 2y, that's 0. And then on the other side of the equation, 3 minus 10 is negative 7. So here you would then get, therefore, okay, 3 dots means therefore. So x is equal to negative 1. Okay? So that is the way to solve the problem. Algebra. Also, you can, yeah, that's just basic algebra. Did you guys understand? Okay, cool. We proceed now with the next one, number 12. So here in number 12, this is basically the same concept, sum of squares. So in the previous problem, guys, we learned the formula sum of squares, correct? But in this case, we are starting from 13 and ending at 33. So the trick there is you just need to get the sum of squares from 1 to 33 and then subtract the sum of squares from 1 to 12. Okay? Yep, that's just subtract. So first perform this part. Okay. Why did we have this? Because we're getting the sum of squares from 1 to 33. So 33 times 34 times 2n plus 1. So 2 times 33 plus 1, that is 67, all over 6. And then on the other side, this part here, this is this part, okay? So 12 times 13 times 25 over 6. Why is it 12? Because your n is from 1 to 12. How is the shortcut derived? Basically, that's one thing that is interesting about math, because when you have this identity, you can it's not derived, but it's basically a trick. It's just a simple trick. Okay, so because the problem is looking for 13 to 33, so if we can get 1 to 33 and then subtract 1 to 12, right? So you'll get 13 to 33. So that's the idea between series of sequences, okay? Yeah, series. This is the concept of series. So you get more about that, Kyle, when you go further in your education, okay? When you go into higher levels of math. So yeah, did you guys understand the problem? We arrived with the answer 11,879. Okay. That's because the sum of squares for the first one is 12,529, and then subtract 650, you'll get 11,879. So did you guys understand that? Okay.
In the
So
exam, we will have the questions, the factories of polynomial.
I'm sorry, Joey, what, can you repeat your question again?
In the in the exam, they will have a question that is factories polynomial.
Polynomial?
Yes.
Yeah. You can also basically in this way we're using the rule that's n times 2n, right? I know n plus 1 times 2n plus 1. So this is the shortcut for sum of squares. Okay? The sum of squares. Factorized polynomial. Yeah. The idea is also basically factorized polynomial. That's right. Okay? So we move forward now with the next question, number 13. Okay, this one. Find the number of all positive factors of 831. So it's a bit hard because you don't really know what are the prime numbers. But when you know how to get the prime numbers easily, then it is gonna be easy for you. So getting the prime numbers would be your first step. So prime factorization is the only way. So 831, when you do prime factorization, you'll get 3 raised to 1 times 277 raised to 1. But we're looking for the number of all positive factors. So we're taking account the exponent. So for 3, you'll have 1 plus 1. Okay? And then for 277, that's 1 plus 1 because you have 1 and then just add another 1. Okay, that is how we solve, that is how you get the number of positive factors. Okay, just add 1 to the exponent of each term. So this is for 3, this is for 277. So the number of positive factors in total would be 4. Okay, did you guys understand? Okay, so we proceed with number 14. So in number 14, a 3-digit number has exactly 3 positive factors. Find the minimum value of this 3-digit. Okay, so 3 positive factors. So this is a bit tricky, guys. So you're looking for exactly 3 positive factors. So the only way that number would have 3 positive factors if it's this number, if this is the number, and then the square root of that would be x, right? So, and then the other number would be 1. So these 3 are the 3 positive factors then. So meaning, okay, you should get a number that has the square, and then you just have to take account the minimum value of this 3-digit number. So meaning x squared here, guys, x squared here should be a 3-digit number. So when you have, what's the largest 3-digit number you would think? You might think of 10. I want to start with
121.
Yeah, it's 121, correct. So, but remember, 10 is when you take the square of 10, that's 100, correct? 10 and 1. But remember that this 100 has also another factor, so it can be 4 and 25. So basically, so you cannot use
there will be
52. So yeah, you cannot use 10, correct? So 10 is not gonna be. So we need to start with 11. So that's why 10, we cannot use 10. So we need to start with 11. Now, if you check 11, that's a prime number, correct? 11 is a prime number. So squaring a prime number would be your best solution. So yeah. So in this case, guys, we should be looking for x squared to be prime. X to be prime. So x here should be prime so that you would not get any other factors, correct? So 11 squared, you'd be 121. So to get exactly 3 positive factors, you need to consider that x there, that particular number that you're going to square is a prime. Okay? So here, the smallest one is 11 squared, which is 121. Did you guys understand? Okay, good. Number 15. So it is known that x is a rational number, and x is greater than 0, and x is equal to 2, square root of 2, square root of 2. Find the value of x. Okay, so the good thing about this problem, guys, it's usually from past experiences, they would not tell if this is equal to x. So there's nothing about this part. They would just basically ask, what's the value of this? So questions like that, you would encounter questions like that. Basically, they would ask you, find the value of this. So the technique there is you use this kind of problem. So you set the actual number to be your x, and that is what's nice about this problem, because it's already stated that x is equal to this number. So you just have to find the value of this one. which is your x also. Find the value of x. So in this case, okay, you would know that the inner part of the, okay, the inner part of the square root, we call that a radicand, right? That's the radicand. So the radicand is basically your x also. So radicand is, you would see that, oh, you would see that it's still the same thing. It's continuous. It's an infinite number. Right? You don't really know where it ends. So you see here, it's square root of x. So x is equal to 2 square root of x. Now we have x on the other side and x on the other side. So you just have to take the square. So x squared is equal to 4x to get rid of the square root. Okay. So after getting 4x, you would know x squared minus 4x is equal to 0. And then factor out x, you would have x minus 4 equal to 0. So one value of x is 0 and the other value of x is 4. But remember, note, okay, note that x is not equal to 0 based on the problem stated. It's x should be greater than 0. Okay? So basically, your answer only would be x is equal to 4. John, yes, you're right. You can divide both sides by x. But remember, we are looking for values of x here. So in algebra, it's not your best method to divide the equation by x because we're looking for x. So if you're dividing it by x, we might miss a number there. So in this case, it's stated that x should be greater than 0. So it gives you an assumption that if I get x equal to 0, that's not the answer. Okay. But if it's not stated in the problem, like there's no statement x greater than 0, basically you can use x equals to 0. But it's not possible. Why? Because in this case, 2 square root of 2 square root of 2 should have a value, right? It should always have a value. Yeah, yeah. Yeah, I understand that, Clive. So, but yeah, but in terms of like the idea of algebra, guys, or idea of mathematics, you don't necessarily do division of 0 because it's not always uh the best way. Yeah, it could be the way, but it's not the best way. Just want to share that kind of knowledge also. Okay. So by the way, yeah, in this case, the answer here is 4. Okay. Okay. So 4 is the answer. Did you guys understand? I think you understood it properly. So we proceed with the next one. Did everyone understand that problem? Okay, so our next problem is number 16. But before we go with number 16, we we might have to take a break, okay? So let's have a break break of 10 minutes, okay? So we'll have a 10-minute break, guys. 10 minutes. So be back by exactly 10.
Before this lesson, I have done this test for in a 15 question. I have 11 correct.
You got 11 correct?
In 15.
In the first 15, you got 11 correct. Right?
Yes.
Okay, good. That's nice. That's nice there. Okay, so Dewey and everybody, we'll have a break. Okay, be back by after 10 minutes. Okay. So in your time, guys, I know we all have different time zones here. So be back after 10 minutes. Okay. Okay. Okay, so is everyone back?
Hello. See you again.
Hello. So I think everyone's back. If you're back, guys, can you just raise your hand on the Zoom, virtual Zoom, so I would know if you're all back. Raise your hands. Okay. Clap. Yeah, you haven't clap. Okay, good. So everyone's back. Nice. Okay, so yeah, you can lower your hand now. You can now lower your hand. Wait, there's 63 of you here. Okay, so lower your hand. Yep, lower your hand. How do I do this?
Excuse me, can you turn back to question 9? I missed it.
Question 9. Oh, you missed it. Anyway, yeah, you want me to discuss question 9 again, or you just want to see how the solution works?
I just want to see it.
The solution. Okay. There, you see it now?
Yes, I see it now. Thank you.
Okay. Right. So we now proceed with number 16. Okay, so for number 16, it is known that x and y are primes. Okay, so prime numbers. So we should always love prime numbers, guys. So x and y are primes. Find the number of solutions of x minus y equals 2015. So when you say x minus y is equal to 2015, this absolute value, this lines here means that you need to take account the absolute value, okay? So absolute value, guys, will always give you positive value or positive number. So if you have negative 3 here, that's absolute value of negative 3 will always be 3. So meaning whatever is the number inside the absolute value, whether it's positive or negative, the result will always be positive. Okay. That's the absolute value concept. Now, in this case, we know that the difference of x and y is 2015. Now, because x and y can be interchanged. Yeah. Why can they be interchanged? Because they are in the absolute value. So in that case, okay, in that case, in that case, the only possible cases where x and y are prime numbers would be this 2017 and 2. You know, 2 is the prime number, right? So the only difference that you could always think is 2 and 2017. So 2017 minus 2, that's 2015. 2 minus 2017, even if it's negative, no? Even if it's a negative number, but remember that it's an absolute value, so it's still equal to 2015. Yeah. You can the trick also here is, remember, their difference is odd. So which is an odd number. If you wanna get the difference that is an odd number, meaning all prime numbers are odd, right? Except for 2. So when you have odd minus even, that is equal to odd. Okay, that is the idea there. Okay, so we want to make it odd. So the only way, odd is a prime number and even is prime number. So the only way here is you have an even number that is a prime, that's always 2. The only even number here that is prime is always 2. So other than that, this should be even. So you would get the realization that the bigger number is 2017. Okay, that's the concept there. Did you guys understand? So the answer here is two. There are two now. There are two. Or there is two solutions possible. Okay, there is two solutions all in all. So two is the answer. Do you guys understand? Okay, good. So we proceed with number 17. Find the integral part of uh this this expression. So what do you mean by integral part? So integral part is basically the integer part, okay? So the integer part. So integral part is again the integer part of this if this sum of fractions. These are fractions, right? We're basically adding 1 to 2018. So if you would notice, the denominator is always 2018, correct? So if the denominator is always 2018, basically you can directly add the numerator, right? So 1 plus 3 plus 5 plus 23 up to 2017. But remember, if we just try to group them in this way, okay, first and then last, and then second to the last, third, and then third to the last. So you would get this idea that 1 over 2018 plus 2017 over 2018, you know that's 2018 over 2018. So 2018 over 2018 is basically 1. So if I try to add these are equal to 1. And then the only difference there is you'll be left with a single number, okay, which is 1009, because 1009 to make it 2018, you need another 1009. But we don't have an extra 1009 in the series because these are like distinct numbers. These are increasing numbers. So there's no way there's two 1009 in this sequence, okay? There is no way. There's gonna be always 1009. So each term here should be unique, okay? So here we would then know that if I just count how many ones I could get, so that's gonna be my answer, right? So in this case, we know that there's 504 of them, okay? 504 of them. So how do you know if that there's 504 of them? So you just have to count, okay, from 1 to 1007. So 1 to 1007 basically, and then that's an odd number. So there's gonna be 504 of them, okay? If you just divide 2018 by 4 to get 504, yeah, 2018 divided by 4, that's 504.5. You would still get the answer. Yep, you can do that, but uh, how how do you think are you gonna arrive at 2018 divided by 4, Clive? Like, what's your idea why you got you got this kind of thinking that I can just divide 2018 by 4? You can talk, Clive. You can share your idea. How did you arrive with that thinking? They have the same answer, by the way. 504.5.
So my idea is that I divided it by 4 because I also solved it like this way po in the screen, and I saw that the last pair is the 1007 and 10,011. That would be 1, right? So basically, since like 1009 right here is just half, that means I could just divide it by 2. But since there's there's pairs, right? That's also 2. So we have two twos, which means that's 4. So I arrived to an idea that 2018, I can just divide 2018 by 4.
Right. Yeah, I get it now. Hey, that's a great insight, Clive. Thank you so much. So, yeah, Clive is right. Basically, since you would find the idea that you would find basically the idea here. 1009 over 2018, that's basically it's doubled. And then since like there's two pairs each, and then so basically you can have in every double, there's basically another double. So dividing it by 4, 2018 divided by 4 would still give you the same answer. Okay, that's right. So the answer here would be 504 now. It is because you're looking for the integral part. Okay, the integral part or the integer part. Okay, so the answer is 504. Okay, did you guys understand? Okay, in the next problem, number 18, it's actually just this, it is actually just the same problem, but you're just asked for the decimal part. Okay, so the decimal part is what you're looking for here. But I think if you were able to arrive with 504.5 from the previous problem, basically you would know what's the decimal part. Decimal part will be just 0.5 or 0.5. So if you could solve the previous problem, basically you can solve also this problem. It's just basically the same process, but instead we're focusing on the decimal part. Did you guys understand? So it's 0.5, okay? 0.5. Okay, we proceed with the next one, number 19. Any questions so far? You guys have any questions? Any
Can you
questions?
return back
Back to
to
the
the question
18.
18?
Yeah, it's actually the same problem with 17. Yeah, so but you're just focusing on the decimal part, so it's 0.5. The answer is 0.5. And we've already also learned
Can
how we
you
arrive at 5.
can you write that one? Can I write that like in a half, 1 and 2?
1 and 2. What do you mean by 1 and 2? 1. Do you mean like the what do you mean doing? Can you explain further what you mean by yes, guys, you will be given access to the recording, okay? So you can just watch the recording so you can screenshot, okay? 1 over 2 Doi, okay. No, you cannot answer 1 over 2 Doi because the question is asking for a decimal part. Okay, Doi?
Yes, I do.
Okay, you understand it now, right? So it should always be 0.5 and not 1/2 because the question is asking it decimal. Okay. So proceeding with number 19. Okay, so number 19, it is known that two sides adjacent to the right angle of a right angle triangle are in the ratio of 1:3. Okay, so there's 1:3 ratio here. It says here 1:3. Okay, it is 1:3. Let me just put it. So the ratio here is 1:3. Okay, the ratio is 1:3. So if the length of the hypotenuse is 14, find the area of the triangle. So how are you going to solve that, guys? So to solve the problem, you need to first know Pythagorean theorem. So we learned how Pythagorean theorem works. So by Pythagorean theorem, the sum of the squares of the adjacent sides or the side lengths would be equal to the square of the hypotenuse. Okay, so 14 is your hypotenuse. So the square of 14 is 196. And then since it is a ratio, meaning they should have a common number, right? Or a common factor. So that's gonna be your h. H here is your common factor. So the ratio then would be 1h, okay? 1h is to 3h, correct? Basically, that's how we arrive at 1:3. So this side here, h squared plus the square of 3h would be equal to 14 squared. So in short, 1 plus 9, 10. So you have 10h squared here is equal to 196. H squared is equal to 19.6. Okay? Find the area of the triangle. So 1/2 base times height would be your formula. So we know that h times h, so this is 3/2. Why? Because h times 3h, 3 would be multiplied with 1/2. So you'll get 3/2 multiplied to h squared. This is h squared now, correct? So 19.6, which we have a value of. So this is equal to 29.4. So the answer is 29.4. But 3/2 because you transfer the 3 from 3h to 1/2. Yes, correct. That's right. That's right, Clive. Yeah. Basically, the constant number 3 was multiplied to 1/2. And I answered 1/7/5. Is that correct? Yeah, it's still correct, Magnus. 1/7/5. That's 29.4. Yeah, it's still correct. Okay. Because it didn't say here how the formula should be answered. I mean, the answer should be in what form. So whether you're in fraction or you're in decimal here, you're safe. Okay. Just give me a second, okay? Give me a quick second. Okay. Hello, guys. I'm back. Sorry for the quick inconvenience. So yeah, we proceed. So yep, I think we're clear with this problem. The answer is 29.4 or 1/7/5. Okay, did you guys understand the problem? Okay, we'll go with number 20. So in number 20, Amy is now drawing.
And then can I read? Can you return to question 19?
We show. Okay. Are you done, Day?
Nearly done.
Anyway, you'll be given recording, Dewey, so you don't have, you can ask the management a copy of the recording or access to the recording, okay? Okay, so we proceed with number 20. For number 20, guys, Amy is now drawing the largest circle inside inside a side length of 30 cm square. What is the area of the circle? So the solution there is 15 times 15 times 3.14, 76.5. But how do we arrive at that? So the technique there is, it's the side length is when you have a square. Let's say this is a square, and then you have a circle. Oh, we wanna make the drawing better. So let's have a square and then a circle. There, somewhat like that. And then we're gonna be placing the circle. Wait. Oops, did we just do that? Yeah. So it's basically like this, but the circle is positioned. Let me just select the circle. Yeah, it should be inside. Yeah, somewhat like that. Okay. So basically it touches each corner, guys. Okay. So it's not over the square, but yeah, it basically touches the edges. So if you notice this part here, or these lines here, you would see that the circle's diameter is basically dividing or bisecting the side lengths of a square, correct? So basically you can divide it by 2. Whatever your side length is, which is 30, is 30, right? So divide it by 2 and you'll get 15. And 15 is going to be your radius. So formula for the area of the circle, that's pi r squared. So yep, r is 15, so 15 squared, which is 225 times pi, which is 3.14. You'll get the answer, 706.5. Okay, but this is the problem. This is an inscribed problem, okay? Inscribed problem. Why is it inscribed? Meaning the circle is inscribed in the square, okay? But it's a different thing when you say circumscribe also, okay? So we proceed with the number 21. The sum in the area of squares, of two squares, the integral side length is 169. What is the side length of the largest square? So the sum of the area of a square. So when you say area of a square, that's gonna be s squared only, right? Area of a square is s squared. So 5 squared plus 12 squared is equal to 13 squared. Okay, where did we arrive with this one? So the sum of the area of the two squares with the integral side length is 169. So since 169, guys, is what the integral side length is 169. So 169 is the area, okay? So meaning this is like Pythagorean theorem in the form of squares, like, right? So we just need to get the Pythagorean pairs, okay? So the Pythagorean pairs here for 13 squared, which is 169, is 5 and 12. So there's no other way, guys, to solve this one, but to familiarize yourself with the Pythagorean pairs. Or the pairs, the perfect pairs. So for 13 squared, that is gonna be 5 squared and 12 squared. Let's say for 110 squared. What is for 10 squared? What is for 10 squared? That is a perfect square. Anyone?
100.
Yep, but what side lengths? That's gonna be, yep, right. So 6 squared and then 8 squared. Correct? Pythagorean triples or pairs. It will be easy. Yes, that's right. So be familiar with Pythagorean triples, so it will be easier for you to like solve problems like this. Anyway, I think everybody gets the problem naman. So yeah, I think everybody gets the problem. So we need to proceed now with the next one. Okay. Number 22. Okay, so for number 22, guys, in a rectangular coordinate system, this point MXY is the midpoint of A and B. Okay, so when we say midpoint, guys, if you try to draw this one in a Cartesian plane, so everybody knows Cartesian plane, right? So the Cartesian plane. So if I try to label this as Y, which is your ordinate, and then X is your abscissa. So, and then points 5, 15. So this is 5, and then this part here is 15. So this is point A, and then B is 7, and then -3. Here, 7 and -3. So that's point here, point B. And then you just have to connect both lines. Okay. And then mark the midpoints. The midpoint there would be somewhere here, right? Or should I use that here? Yep. Yeah, it should be somewhere here, right? Yeah. So in this case, to get the X and Y here, you just have to either draw it geometrically or use the formula. So for midpoint, you just have to add x1 and x2 all over 2, and then for y, y1 plus y2 all over 2. So since we're looking for x and y here, so 5 plus 7, that is going to be 12 over 2 is 6. 15 minus 3, 15 plus -3 is 12 over 2 over 6. So meaning the midpoint is 6, 6. Okay. And it's clear also in the graph, right? You would know in the graph that it matches the concept, right? It's gonna be here, which is that's 5, that's 6, and then here it's also 6. So that is basically the concept behind a midpoint. Okay, midpoint. So did you guys understand? So the value of x and y is 12 because you are adding x and y, and they are both 6, so 12. Did everybody understand? Okay, cool. So proceeding to the next one. Number 23. What is the sum of exterior angles of a nonagon 9-sided polygon? So sum of exterior angles, when we say sum of exterior angles, guys, it is always given that it should be 360. Yep. The sum of exterior angles in any polygon is 360. It's 360. Yeah, but you want to know what's going to be the measurement of each exterior angle, that you just have to divide 360 by 9. Okay, 360 by 9, that will give you that particular number. So 360 is the answer, guys. Any question? why it's 360. Basically, that's the rule. That's geometry. So no question. We proceed now with number 24. Okay, for 24, refer to the attached figure a minus b plus c minus d plus e is equal to 0. Find the value of f plus g. So f plus g, guys, we're looking for f plus g. Where is f plus g in the figure? So f plus g is this one, right? This is angle f and angle g. Okay. But remember, what you have to check here, guys, is because we have this identity that if there are two angles, two interior angles on the same side in a transverse axis, or no, it's not a transverse axis, but parallel lines. When you have this kind of form, guys, when you have like two lines in geometry, when we have two lines that are parallel, assuming they are parallel, and then there's a bisecting line, third line bisecting, this angle here and this angle here would always be supplementary. And then this angle here and this angle here would always be supplementary. Okay? So in this case, guys, if we assume already that this line here, this side here, and this side here are parallel. So if they are parallel, guys, then these angles G and F, which are on the same side also, would be supplementary. So they're supplementary. So a total would be 180 given. That's given. So you would get it would give you good guess. Okay. And the good guess here is they I would always answer 180 directly because based on the figure, they look like they are parallel. So no further thinking, my answer would be 180 because they are supplementary. Can you assume A
Sir,
plus?
excuse me, sir.
Yes, Kyle.
I mean, couldn't be just easier for to do like uh for the to like calculate the sum of the interior angles first and then sum of A and then the interior angle version of B like like the 360 minus the angle B.
Minus B. So you would
So
like
like
A minus
so just like convert them into like the interior angles, something like that.
C plus. You have something like this.
Ah, yes. Then I just have to calculate the sum of what usually would be the interior angles, sir.
Yeah, and then the sum of all the interior angles is 360, right? No. Well, what Kyle, may I know what's your point of like doing it this way? Do you know what's the sum of the interior angles here? Or are you sure that like 'cause it might be hard for you to like know the sum of the interior angles. So I think the best solution here, guys, is you need to first you just need to like verify if it's parallel or not. So actually this solution part here is basically verifying that they are parallel. Okay. So you would notice that B here was divided by B1, B2. Why is it divided? Because uh, it's assuming that this is B1 and this is B2. This one is B2 here, there's B2. And here it's also divided B1 and this one is B2. So when you have two angles, guys, Okay, this one and this one will always be equal. That's the beauty of having this kind of theorem. This is absolute theorem in geometry. Okay. Can you assume them? A plus B is equal to B. It's a long shot, Clive. You cannot directly assume that A plus B is equal to B just because of how they look like, but and because we don't really know how to like associate A plus equal to B. So like they are far with each other, and then the lines will not be the same. So it's hard to assume that. You cannot do that. Okay. Okay. Easy. Okay. Any other question, guys? So, Kyle, did I give you a fair answer? Was that clear? Was my answer to your question clear? Okay, good. Good night. Okay, so everybody, we proceed now with the next question since we don't have any more questions with this problem. Basically, the answer there is 180 again. It's because we need first to prove that it's parallel. And then remember that when you have interior angles on the same side of two parallel lines, okay, they are equal. But when they are alternating, not on the same side, they would be the same, okay, equal. So when alternating, they are the same, but when parallel, or no, I mean, when they're on the same side, that is going to be supplementary, okay. So proceeding with number 25, if Andy goes from point B to point A, each step can only move down or move left. How many ways are there? So there's 23 ways. How do we solve this? Again, this is basically the same as the previous problems that we had. Counting, you just need to do counting. So to arrive at this way, you have one way. To arrive at this point, there's only one way. No, there's two ways now. Why is it two ways? Because you can either go here or go here. So here you have one way to reach there. So to arrive at this point, there's two ways. To arrive at this point, there is how many ways? One. Okay, still, okay? Because you can either move down or move left, right? So moving down, moving left, moving down, you cannot move right, right? So that's not possible. Move down or move left only. So here you have one way. So all these sides here would be one way. One, one, one. And then the inner part here, I think there's only one way to go here. Okay. Because it either move left, move left, move left, and then move down. Right? To arrive here, there's two ways. To arrive here, there's three ways. To arrive here, there's three ways. To arrive here, there's three ways. So how did we identify if there are three ways there? Basically, what the technique here, guys, is you need to add the adjacent numbers. Okay. To arrive here, that is 3 plus 1. So 4. To arrive here, that's 3 plus 3, 6. Here, that's 10. Here, this is 5. Here, this is 8. Here, this is 15. So 15 plus 8, 23. So now we see that we ended up with 23 ways to arrive from point B to point B. So did you guys understand this? Understood? Yeah, good. No questions, I think so. We proceed to the next one, number 26. For number 26, guys, it is given that the total weight of 4 apples and 3 melons is 1/7, and the total weight of 3 apples and 4 melons is 1/8. What is the weight of an apple? So here, the solution here is a bit of a shortcut way, or it's like it requires greater understanding. But 1/7 plus 1/8 basically is the total weight divided by 7. Now you might question why is it divided by 7? Because that's if you have the first condition, 4 plus 3, 3, that's a total of 7 items. 3 plus 4 on the second condition, that's a total of 7 items again. So 5 divided by 7, you get 500. And just give me a second, guys. Okay? Okay, so going back to the problem, basically 1/7 minus 500 times 3. So 500 because, yeah, we divide 55 divided by 7, and then there's 3 apples. We assume that we know that there's 3 apples given on this in this sentence, right? So 1/7 minus 3 apples, knowing that 500, assuming that 500 would be the grams of each apple, we would get 200. Okay, but how do we put this in an algebra way? So in an algebra way, guys, to solve it in an algebra way, you need to put apples plus okay, so basically 4 apples plus 3 melons is equal to 1/7. And then the other one is 3 apples plus 4 melons is equal to 1/8. Okay, so if you take account, what the technique here is you multiply this just to eliminate melons. You need to eliminate melons. So multiply this by 4, correct? So if you multiply that by 4, this becomes 16 apples. 4 times 3 is 12. No, you need to multiply it by 4/3. 4/3. Okay, multiply it by 4/3 to eliminate melons. You want to have like 4m also here. So 4/3 times 4, this is 16 over 3 a plus 4/3 times 3m, that's 4m. And then 4/3 times 1/7, how much is that? 4/3 times 1/7, that's 6,800 over 3. (6,800 over 3), correct? Over 3. So now we can then subtract this one, okay? Just to eliminate 4 melons. So 16 over 3 over minus 3. Okay, minus 3, that is 7 over 3. So this is 7 over 3 apples minus 0 melons now, because 4 minus 4 is 0. And then 6/8 over 3 minus 1/8. That's gonna be 1/4 over 3. So you would see, you can cancel out the denominator 3. You'd be left with 7a is equal to 1/4. So a is equal to 200. So in this way, by using this also, you would get the same answer. Okay. So this is like the algebra way, basing on the given statement. Do you guys understand? Okay, so going to the next one, number 27. We have 50 students here in grade 7, 29 in 23 students like playing basketball and volleyball, and then 4 students like both ball games. So how do we do this? This is easier, guys, when you like apply Venn diagram. So Venn diagram, we have like two, let's say there's like two circles, okay? And then, so there are 50 students, grade 7, 29 and 23 students like playing basketball and volleyball, respectively, okay? So they both like, so 29 and 23 students like playing basketball and volleyball, respectively. So the total of this would be 29. Now the others would be 29. And then this one is, oh no, this one is 29, sorry. And then this one is 30, 23. This one's 23. Okay, so 29 and 23, you then have 4 students like both ball games. So the common there is 4 students, correct? So 4 students like both ball games. So 4 of them like both ball games. So find a number of students who don't like both ball games. So easy solution here is 50 minus 29 plus 23 minus 4. Why do we have 4? Yep, this is set theory, correct? That's right, Jan. Okay, you need to subtract the intersection there. So why do you have minus 4? Because that's the common of them, right? So 50 minus 48 is 2. So there's gonna be finite number of students who don't like both of them. So there's a 2 outlier here who doesn't like basketball or volleyball. So basically, to get the number of students there is do this. Okay, 50 minus 29 plus 23 minus 4. So meaning there's 48 people who like either basketball or volleyball. If you would ask why we minus 4 here, because they are common to both sides. So 29 has 4 people, 23 has 4 people already. So minus 4 because they are common on both sides. Yeah, this is what union, correct. Union. So this is basically a union A plus B minus the intersection of A and B. That is what John Kenneth is saying in the chat. Okay. And then this is the total number, which is your whole set. So basically the answer is 2. Did you guys understand? Understand? Okay, good. So we proceed with the next one. Number 28. When do the hour hand and the minute hand form a right angle between 5 p.m. and 6 p.m. the earliest? So when we say the earliest, guys, so if you look at the watch, let's say 5 p.m. This is 3, 4, 5, and 6. This is 5 p.m. and 6. So they should be right angle earliest. So there's 2 possible ways. They could have in this form or in this form, correct? But this one would be your earliest. Why? Because that's gonna be first. That's gonna be the first right angle to be formed. Not this one. This one is right angle, but also it's the second early. It's not the earliest anymore. Okay, that's why it's stated there that it's the earliest case. So the earliest case would be in this form, correct? So the technique there is to get the difference between the 2 clocks. So why is it 60? It's 60 because each side, so you know that each side is Okay. The difference, okay, that's 4 times 15. 5 and 6 p.m. Yep. Remember that is 15 degrees. Each length here, guys, is 15 degrees, correct? So, okay. Why is it 60 degrees? Because you might think, why is it 60 degrees, sir? It is because to form a right angle, guys, what is a right angle? That's 90, correct? 90 degrees, right? 90 degrees. But how many minutes did it pass to get 90? Remember, in a clock, guys, you have like 12. So 360 divided by 12. How much is 360 divided by 12? That is 30, right? So 360 divided by 12 is 30 degrees. So every time the hour hand passes each minute, okay, that's equal to 30 degrees. So this is 30, 30, 30. So going to fifth, that's gonna be, what is this time? This is gonna be 5 times 30. So 5 times 30, how much is that? That is 150, correct? 150. So 5 times 30 is 150 minus the 90. Why did we have to minus 90? Because that's going to be the right angle form that we want to have. So we're basically subtracting the angle of the hour hand and the minute hand. The difference in their angle is 60. Okay, 150 minus 90 is 60. So divided by 5.5. Remember, guys, always remember 5.5 is a constant thing in clock problem. You don't have to like ask 6 degrees minus 0.5 degrees. You can research about that. You can like check it on Google, online, and the internet. But basically, 5.5 is a constant number that you need to associate in clock problem. Okay? Because okay, so 60 over 5.5, that's gonna be 10 and 10 over 11. So the time would be, when do the hour hand? That's gonna be 5 p.m. and 10 over 10, 11. So when did the hour hand and the minute hand form a right angle? The time would be, what's the particular time? So that's 5, 10, 10 over 11. So this is the particular time where the hour hand and the minute hand would form a right angle. Okay, did you guys understand? Okay, perfect. So we proceed with number, no questions, I think. So we proceed with number 29. So Andy has 28, 10, and $20 banknotes. All together, he has 420. In total, how many $10 banknotes does he have? So to solve this in an algebra way, so let's assume $10 banknote would be X, and then this would be Y. So X plus Y in total would be 28. 28 banknotes, correct? But $10 times X, which is the number of $10, and then $20 banknotes.
Can you return to question 28?
What did you ask, Dewey?
Yes, can you return to the question 28?
Oh, question 28. Why? I forgot, right? Okay. Are you good now?
Done.
Okay. In this way, guys, yeah, you can request. It will be emailed to you guys. The links will be emailed to you. This recording is gonna be given to you. You'll have access for this. You don't have to worry about going back on another problem. So, okay. So again, X plus Y here is gonna be 28. Then X plus 20, Y is gonna be 420. So by method of elimination, we want to get the number of $10 banknotes. So we multiply this by 20. That is to get out $20 with banknotes, correct? So 20, that is going to be 20x plus 20y. 20 times 28, that's 480, right? So if you then subtract both 20x minus 10x, that's 10x. That is 0y. So 480 minus 420, that is 60. So x would be equal to, oh wait, it's this one's wrong. 480, it says 480. It is that is, how much is that? 560. Yeah, it's 560. So 560. So therefore 560 minus 420, that is 140. Okay. So this is 140. So 10x is equal to 140, x is then equal to 14. So meaning there are 14 $10 banknotes, okay? So yeah, that is how you do algebra here. Okay, did you guys understand? Okay, so let's proceed with our last problem. Last problem is a combination problem. There are 11 boys and 5 girls in a class. Choose 3 boys and 2 girls to form a study group. How many ways are there in total? So when we say number of ways, so this is combination, correct? But the thing here is your condition is you want to have 3 boys and 2 girls. Take note of the word and because it's different with or. And or are different. When we say and, we multiply. Okay? But when we say or, we add. Okay? So here, the number of ways to get boys, 3 boys, and the number of ways to get girls, 2 girls, would be multiplied. Okay? So why is it 11 CR? It's 11 CR because we want to choose 3 boys, and it doesn't matter what's the order, but as long as they are boys. So this is not permutation problem because we are not careful with the order. Okay, we're not specifically asking for the order, but basically we just want to get 3 boys, choosing 3 boys. So usually, guys, if you like get the word choose in the problem, if that's already your clue that this is going to be a combination problem. Okay, so here 11 combination of 3 is 165, 5 combination of 2 is 10, so multiplying them 1650. So I assume you know already the process of getting this because that's a combination, and I think you know how to do that. So basically that is your answer to this problem. That is how you solve it, guys. Do you have any questions? 1650 is our answer. Did you guys understand? No questions? Did you guys understand? Let me know. Yeah, we only have like a minute left. So I think that ends my presentation. So thank you so much for listening, guys. Good luck for your finals.
Excuse me, can you turn back to exercise 21?
Oh, exercise 21. 21.
2 minutes left.
21. 21. This one. Anyway, you'll be given recording, so you don't really have to. But yeah, let me share it to you. Okay, so this is 21. Just to give you. Are you now good, Lee? Was that?
Okay, thanks.
Okay, great. So yep, I'm gonna stop sharing now. Thank you so much, guys, for coming here. It's already 10:59. Yeah. So any more questions?